The random variable x has a binomial distribution with parameters n and p. It is given that expected value of x is 3.5. A. Find the least possible value of n. The expected value is equal to np. This formula is given in a data booklet and it's 3.5. And we know that probability is greater or equal than 0 and less or equal than 1. Hence, we get that 3.5 divided by n should be greater or equal than 0 and less or equal than 1. And hence the least possible value of n is 4. The next question. It is further given that probability that x is less or equal than 1 is equal to this value. Correct to 4 significant figures. B. Determines the value of n and the value of p. So we can consider this function, and we need a point of intersection. Or it will be more useful to move it to the left and it is equal to 0, and hence we need to consider only one function which is equal to the left hand side, and the right hand side it's y is equal to 0. It's just x-axis, and hence we need, when y is 0, so we need x-intercept or zeros of the function which is equal to the left hand side. So we need to consider this function and let n be unknown value, so it will be x when we use the calculator. So we choose function y and we consider this function. What is probability that x is less or equal than 1? It's binomial, and if we consider x is less or equal to some value, so it will be binomial CDF up to 1. Or we can consider, since there are only two possible values of x, we can consider probabilities that x is 0 plus probability that x is 1, and probability that x is equal to 1 value is binomial PDF. So here we choose by second distribution and binomial CDF. Let x be unknown parameter, which is n, so number of trials it's n, so it will be x, and p, hence it's 3.5 divided by x. X value it's 1 because x is less or equal than 1, since it's binomial CDF, and enter. So we get binomial CDF, then minus this value, so that we get a function which is equal to this the left hand side. And then we can consider graph, or we can consider table, and we need the left hand side or a given function to be equal to 0. And we can see that for x is 9, it's negative, and it's positive, and it's 10 to negative 6, so it's very close to 0, so it's the required value. N is 12, so that this function is equal to 0, so n is 12, and hence p is 3.5 divided by 12. Divided by 12. So probability is 0.292 to 3 significant figures. And that's all for this question.